Happy Tuesday, everyone. This week we're doing things a little bit different. I was recently able to go on site with the crew from ECS to do a large building blower door test where we ended up using 9 fans. So I'll be interviewing Steve from ECS and he'll explain what that process looks like and what that kind of work entails. Hi, I'm Sam with Retrotec and I have Steve here with ECS and we just did a large building blower door test. If you're familiar with residential testing, this is a totally different beast. This ended up being a 9-fan test, as you can see behind us. Was going to be 13.
Yeah.
This is actually a really tight build, so we could drop 3 and then start off. We actually put rings on all the fans to start off. So, Steve, what's it take to prepare for something like this?
Well, as you know, there's a lot that goes into this. A lot of preparation before you even get to the site. I mean, it's talking with the general contractor and determining, you know, what exactly is our goal here. You know, what is the expectation of pass-fail? Some of these buildings might be 0.25 CFM. Some of them have been 0.4. This one we were testing to 0.25. A little bit tougher standard, but as you can see, I mean, this test went just fine. The coordination as far as getting this amount of equipment, I mean, there's a lot that goes into it. You see cords everywhere. Getting the right personnel, people that know what they're doing. You can't just have a bunch of hands, clearly. So it's pretty cumbersome.
Yeah. And so when you say 0.25, that's 1/4 of a CFM per square foot of the total envelope area. Mm-hmm. So yeah, that's going to be a pretty tight number. And I think we came in at 0.12.
I believe so.
What our final number was?
Yeah.
So yeah. What kind of equipment does this test involve? What's the setup look like? How many people are needed for something like this?
It depends on how many fans you have. So, you know, if it was just one fan, you know, maybe 1 or 2 people can handle that just fine. This one being that it was 12, kind of like to base it off of how many test locations we have. So this one we had, at this location we had 1 other. So at minimum, I want to have at least 1 guy, all hands on deck, always paying attention to that location. We also have 1 person, you know, manning the fans. So there's 1 person at the laptop, controlling all the fans, making sure everything's working properly. This one being that this particular test location was 9, I like to have at least 2-3 people to you know, monitor them, you know, moving fans around, moving equipment around, and just all the additional things that are required to get this test done.
Right on, right on. So yeah, we have a laptop that has software that runs everything from 1 location. As I mentioned before, we had another bank of fans that we were fortunately able to just drop off. We didn't need them.
Yeah.
And so one of the concerns we had was, okay, well, if we have all of our fans in 1 location, how do we know that the whole building is getting under that target pressure? So what we were able to do is just have a manometer reference the outside and that other end of the building, and we could see, hey, we're going to shoot for 50 pascals. Let's see if we pick it up on that end, and we did. So that's we felt comfortable with the readings we got from that.
All right, it's good to double check that.
Yeah. So what if a building is leaky? What are some ways to go and find that?
So there's a couple different methods that you can use to troubleshoot, to diagnose air leakage. One we did today was infrared, so we pressurized the building and we're able to use the infrared camera to see points of air infiltration. So it's gonna show up as some wispy anomalies on the camera. So that's probably our number 1, our easiest method. There's also smoke pencils, where, you know, if it's pressurized, there's air leakage coming in or out of the building, the smoke's going to kind of follow that. So that's pretty easy. And then obviously you have, just use your hand.
Sure.
Let's see if we feel something here.
Yeah, yeah.
It's always your safe bet there too. So
yeah,
there's multiple ways that you can do that.
And this is good weather for infrared. We're in the Northeast in the winter, so
yes, large temperature difference.
As we depressurize the space, we're sucking air out so we can see that cold air come in wherever the leaky spots are.
Yep.
Yeah. Well, Steve, I think this was a success.
I think so too.
Yeah, the builders did a great job, and hopefully to catch you in the field again.
Yeah, I like that.
Cool.